Second. All right, so here we have an AP, and for an AP, there is a common difference of 2. The difference is something. So here the difference is 3, right? Between 11 and 14, there's a difference of 3. So you can see between every consecutive terms of an AP, there is a difference of 3. For a GP, there is a ratio R. A common ratio means you have to multiply with that value to get the next term. Coming back to AP, 11 plus 3 is 14. 14 plus 3, 17. And then 17 plus 3 is 20. Now here it's not plusing, but you're multiplying. Okay, so into 2. So 3 into 2 is 6. Then 6 into 2, 12. Then 12 into 2, 24. 24 into 2 will be 48. Okay, so that's the only difference between AP and GP. For AP, there's a common difference. For GP, there's a common ratio. Okay. Now, how did we find this D? In AP, how did we find D? We just have to subtract any two consecutive terms, right side minus left side. In GP, how do you find R? You have to divide. So 6 divided by 3 will give you 2. Or you can do 12 divided by 6. Or 24 divided by 12. So any two consecutive terms you can divide to get this R. Is it clear, Aman? Okay. The first term is still represented with the same alphabet. What is that? A. Okay. The last term is also represented by the same alphabet. L. N is also same number of terms. S is same sum of terms. First term is T1, T2, T3. That is also same. Everything is same. The only difference is D is replaced with R. In place of D, we have R. Okay. Now, again, let's compare. In AP, how do we find Tn? Nth term. What was the formula to find Tn? A plus N minus 1 into D. This was the formula, right? In GP, to find Tn, you will replace all the additions with multiplications. Let's see, and then we'll compare, okay? So the formula here is A instead of plus into, and this N minus 1 into D, we'll write it as, in place of D, we'll write what? R, and N minus 1, we'll write it as the power. And in between this, it's a multiplication sign. So you don't need to write the multiplication. You can just write it like this. Tn is equal to AR raised to N minus 1. This is the formula to find the nth term. It's very similar. Instead of plus, we are writing into, and instead of into, we are writing raised to power. And obviously, in place of D, we are putting R. Did you get the formula? So what's the formula to find Tn? A into R raised to N minus 1. Okay. So let us use the same example to find some term. Let's find the fourth term. Okay. Okay. So we'll find what is our aim is to find what is the fourth term. We need to find what is T4. So what's the formula to find T4? Put the values. A is what? We're using the same GP, okay, as our example. So A is what? A is the first term, that's 3 into R. What is R? 2. 2 raised to N is 4. So N minus 1 is 3. Got it? So that is 3 into 8. 3 into 8 is how much? 24. See, we got 24. The fourth term. Okay. So we have just tried an example to find the nth term. Okay. Now you will write down this much, and also then you'll find the the seventh term. Okay, write down this whole thing, and also find the seventh term of this GP. To find the last term, we are modifying this Tn formula and putting L in place of Tn. So L is equal to AR raised to n minus 1, where n would mean the number of terms in the GP. Okay, from exercise 11a from this book, do question 2. Find the 9th term of the series. Question 2. Okay, anyone got this answer?
I don't understand what is the n.
N is the number of term. So here 9th term means T9. We have to find T9.
So in the formula, AR equals to n minus 1. So what the n will be? To find n.
We have to find T.
Oh, that T is n.
T is not N. T is the term, N is the number of the term. See, for example, here 1 is the first term, 4 is the second term, 16 is the third term, 64 is the fourth term. Okay, so this is the fourth term, right? So here N is 4 and T4 is 64. Understood? See, for 16, what is N?
Is 3.
3. And T3 is? Yeah, which is? T3 is 16. Understood? So here we are finding T9. So N is 9. If anyone got the answer, please tell me. Oh, 4 raised to 8 you have to do. You didn't get that over. Huh? Why? 4 raised to what you got?
9.
Oh, 9.
Because 9 will be n.
Yeah, but it's 9 minus 1. No?
Oh.
You put also there n minus 1.
Yes, yes.
So 9 minus 1. So it will be 4 raised to 8. Ah. How much? I'll show you an easier way to get 4 raised to 8. Okay, you can do 4 raised to 4 into 4 raised to 4. You know, in exponents, we have learned that you have to add the powers, 4 plus 4 to get that 8. So you can do separately 4 raised to 4 and then multiply twice. Instead of doing that into 4, into 4, into 4, into 4. Okay? See, what is 4 raised to 4? 4 fours are 16. Oh, that also again you can split. You can split it as 4 square into 4 square. You'll get 4 raised to 4. So again 4 square into 4 square. So in other words, you can just do 16 into 16 into 16 into 16. So first you do 16 into 16. 256. And then 256 into 256. You just have to do this one multiplication. That's more easier, no? Okay, do this fifth question. It's not there. Show me what all is there. Just hold on, everyone. But it's similar questions are there. Do this. Do fifth. Okay. Huh? Yeah. So the numbers are decreasing. Okay. A is 12. How do we find R? R is not 3. You have to do 4 upon 12, correct? 4 upon 12 is how much? What? 1 upon 3, not 3. Okay. R is 1 upon 3. Now find T10. So T10's formula is AR raised to 9. Put the values in this formula. I'll just make a small change. Don't find the 10th term. Find the 6th term. Okay. Change the question. Instead of find the 10th term, find the 6th term, because 10th term will be too difficult. Okay. Find T6. Hmm? Yeah. Yes. Leave your answer in mixed fraction. Yes. Check the divisibility test for 3. Did you all get the answer? See, a question is in mixed fraction, no? So your answer also should be in mixed fraction. Okay, so T6 is equal to 12 into 1 upon 3 whole raised to 5. So that means 12 into 1 upon 3 threes are 9, 9 threes are 27, 27 threes are 84, 84 threes are 81, 81 threes are 243. So you can cut this in which tables? 12 tables. 3 tables. 3 fours are here, 3 eights are 81. So your answer is 4 upon 81. Finished, no? Huh? It's a proper fraction. How can you convert proper fraction to mixed fraction? Only improper fraction can be written as mixed fraction. Improper fraction means where the numerator is greater than the denominator. Those fractions can be converted into mixed fraction. This is your answer, 4 upon 81. What you all were trying? Ivan? How you do this mixed fraction? See, it's like this. It's 4 divided by 81. This is how you're at 4 upon 81. Then it will go 0 point, it will become 0, 0. You cannot convert proper fractions into mixed fractions. Okay, next question. This is your book now. Question number 9. Or let's do 8 first. Look at 8. Let's do 8. Before doing word problems, one question from here. Question 8. Okay, look at the question. What have they asked? It's the same logic that we've used for AP. Tell me what we have to do here. Yeah, so in this AP, I mean in this GP, minus 5.72 is there. We have to find its position. So we take this minus 5.72 as the last term. Okay, this is your L. And you have to find what is N. So N will be the number of terms, which would be the position of that, the last term. You understood, everyone? Consider this value as the last term and find N. That's all. You're not there for AP or what? Okay, same logic, no? We've done this so many times. So A is what? Minus 10. Find what is R. We have L. Find N. The formula is L is equal to AR raised to N minus 1. Yep. Do it. So R is the same thing. 5 upon root 3 divided by minus 10. Right? Divide like this. If it's fractions, then we can write this as 5 upon root 3. Convert the division into, and here you'll write it as minus 1 upon 10. Right? You'll reciprocal. So that becomes 2. And so R is what? Minus 1 upon 2 root 3. That is R. Okay. All right. You all rejoin the meeting. Okay. Are you all getting something here? Okay. So let's do L is equal to AR raised to N minus 1. We have the last term, which is minus 5 upon 72. That is equal to A is minus 10 into R is minus 1 upon 2 root 3 and raised to N minus 1. Correct? Yes. Okay, how do we solve this now? Now in indices, when do we minus the powers? Law 2, there was 7 laws, no? In law 2, when there's division, same basis, and there's division, that time we minus the powers. So now we're doing the reverse. The reverse means it's already minused here. We will write it as divide. Okay, so just watch. So minus 5 upon 72. Let's take this minus 10 on the left side. What will happen if you bring it to the left? No, it's multiplied. So it'll get divided. Means the 10 will come in the denominator. Clear? Equal to, here on the numerator we'll take minus 1 upon 2 root 3 raised to n, and in the denominator we'll take minus 1 upon 2 root 3 raised to 1. See, normally we used to do the reverse order, right? When the bases are same and the powers, and you're dividing them, what do we do with the powers? We will minus, no, n minus 1. We normally do the reverse. Bases are same and there's division in between. That time we minus the powers. So here we're doing it the other way. Clear, everyone? Okay, so from here it will be more easier to solve now. So LHS we can cut 5 and 10 and the minuses also. So that will be 1 upon 144 equal to, here this division will convert that into multiplication. So that will be minus 1 upon 2 root 3 raised to n into 2 root 3 upon minus 1. Yes? Okay, now can we cut? Huh? What? Anything? See, it was raised to 1 luckily. So you don't have to write the raised to 1. Yeah? We just converted the division to multiplication, so we reciprocal this side. Okay, what's next? Can we cut 2 root 3, 2 root 3? We can't cut because it's whole raised to n. Okay, so what should we do? Take this on the left side, so all numbers are together. So on the left side we have 1 upon 144. Then into minus 1 upon 2 root 3. The into will become division, which means this gets reciprocal here on the left side. And on the right side we have minus 1 upon 2 root 3 raised to n. Okay. Now what is 144? 12 square? 12 12s are 144, no? Okay, if you factorize 144, prime factorize, okay, 272s, 236, 218s, 2 9s, and then 3 3s are. So on the numerator we have minus 1. In the denominator we'll have, wait, what do we do here? Or if you just multiply 144 into 2, that will be 288 root 3. See, what normally we have to do is, we need to get on the left side also same base. That is what we are supposed to get. But the base is not coming same here. How do we do?
On the LHS page, will be the
Same?
Okay.
Same?
The denominator,
Huh.
like past multiply will be the same.
Right, how?
How will be in addition?
Between these two? Then?
The right side one, you find it. On top, 144.
Here. This is multiplication or direct multiplication. Just check the answer behind, no? Is this in your book? Yeah. Fifth term is the answer. Okay. Okay, coming back one step. Here, huh? See, this 144 is what? 2 into 2 into 2 into 2 into this 2 into 3 into 3
How about we put like do 144 root, that would be 12.
Yeah.
And if we prime factorize 12, it will be 2 root 3.
Okay. All right. Yeah, that'll be better. So 144. Um, wait. How do we write that neatly? So your answer is coming, but uh, okay. How many twos are here? When we prime factorize 144, we got 4 2s, and this 1 2 is here. So that's 2 raised to 5 and 2 3s. That is 3 square, and then into root 3. If I put a whole raised to 5 over here, so 2 I can just write 2 inside, because if I'm taking the 5 outside, and here 3 square into root 3. How do we do that? See, you're supposed to get a root 3 over here. Yeah, actually it's correct. See, what is root 3 raised to 5? Root 3 raised to 5 means root 3 into root 3 like 5 times, right? From that, root 3 into root 3 will become 3. And this root 3 into root 3 also will become another 3. That's why you have this 3 square. And then you have the 1 root 3, which is alone there. So we are getting this, but not in the right way. Okay. So it is coming minus 1 upon 2 root 3. This whole thing is becoming is equal to 1 upon 2 root 3 whole raised to n. So when the bases are same, therefore 5 is equal to n, or n is equal to 5. Okay, but we need to figure out how to get this in the right way. Huh?
How did we get this one?
How did we get?
Minus 123.
See, 2 raised to 5. You see, there's the 2 raised to 5 that we already have here. And root 3 raised to 5. Root 3 raised to 5 means, I showed you know, 5 root 3s. So 5, that becomes 3 square into root 3. That's how. Yeah, so some questions are a little confusing like this. Now, like this, complicated ones won't come. You'll have direct questions only mostly, okay?
Check on knowledge book.
Hmm?
It's a website. So every check on knowledge book. Knowledge book, 10th standard maths seminar. I put the chapter 11.
Knowledge boat.
Yes. No space. No knowledge book. Yes. Yeah.
Okay, question 10. Fourth and seventh terms of a GP are 1 upon 18 and minus 1 upon 486 respectively. Find the GP. So similar to AP where they had given you 2 terms and we had to make simultaneous equations and solve it, right? Yeah, but here you won't get exactly that type of simultaneous equation, but same method, okay? So fourth term, that means, hmm? So T4 is 1 upon 18. And T4 is represented how? AR raised to 3. AR raised to 3 is 1 upon 18. Okay. And then T7. T7 is minus 1 upon 486. So that is AR raised to 6 is minus 1 upon 486. Okay. Now how do we simultaneously solve these two? Make A the okay, make A the subject and then okay, yeah, that's there. I'll show you the easier way how you have to do this. Okay. So normally in simultaneous equation, you will do first equation plus second, or first equation minus second, or second equation plus first, or second equation minus first equation. Here you will divide. Okay. So let's do second equation divided by first equation. So that will be what? AR raised to 6 is equal to minus 1 upon 486. Divide with AR raised to 3 is equal to 1 upon 18. Okay. So when we're dividing, see the A and A will get cut. Okay. And then here we have R raised to 6 upon R raised to 3. So what will that become? Subtract the powers. R raised to 6 minus 3 equal to here. How will we divide fractions? Minus 1 upon 486. And this division will write it as multiplication, and reciprocal this 18 upon 1. So we will get, yeah, we can cut also. So here we'll get R raised to 3 is equal to something. And then if you do cube root on both sides, we'll get the value for R. Did you understand what to do? Okay, continue. Do from here. Okay, you're able to cut this.
Yes.
What did you get?
Minus 1 upon 27.
27? Did you all get this?
Yes.
Okay, so R cube is equal to 1 upon minus 1 upon 27. So what is R? R is equal to minus 1 upon 3. Right? Cube root of 27. Okay, so we got R. Now we need to find A. Did anyone get A? How do you get A? You substitute this value of R in any one of the equations and find A. Put the minus on the numerator. So minus 3 upon 2. Now we have to find the GP. So find the GP means write the first, second, third, at least 3 terms. Is everyone clear till here? Oh, wait. See here.
Minus 1 upon 3.
R is minus 1 upon 3 only. In place of R. Huh? Yeah, there's a cube, no? I mean, that's the equation. Any doubts? Which one?
One.
-1 square becomes +1. There's a minus into plus. Yeah, but minus is still there. Only the number gets cut. Okay, so in this chapter you only have 2 exercises. Last year's book had like 4 or 5 exercises. Okay, so they have cut short, made it short, and so this is the first exercise where you're using this one formula, t, finding the term. The next exercise is where you're finding sum. Okay, that has some 2 or 3 formulas to find the sum. Okay, that we will do later on. So your homework is to finish up this exercise 11a. Okay, do as many questions. The more questions you do, the better it is for you. I'm not saying do this, but all of the questions, if you do, the better for you. Okay, at least do 5 or 6 questions from this. Okay, all right. So we're going to physics today. All right, question 6. Find the 7th term of the GP. So T7. Formula to find T7 is AR raised to 6. So A is root 6. Wait, what? This one, no? A is root 3 plus 1. Yes? Into R. What is R? Okay, so we need to first find R. So R is equal to 1 divided by root 3 plus 1. Okay, that's it. That is the, sorry, that is the R. So R itself, the rationalize. Okay, the R itself, you rationalize the denominator. That means you multiply this with root 3 minus 1. Numerator also root 3 minus 1. So that will be root 3 minus 1 upon, this is in the form of a plus b to a minus b. So that will be a square minus b square. That is 3 minus 1, which is root 3 minus 1 upon 2. Okay, so that is the value you take for R. Yeah, this is a into R is root 3 minus 1 upon 2, no? So here then whole raised to 6. This is your R, root 3 minus 1 upon 2, that whole raised to 6. Okay, so what Beryl did here is root 3 minus 1, there are 6 of them. So one of them will take it out. So it will be root 3 plus 1 into root 3 minus 1 into, now the remaining, how many of them are there? There is 5 of them. So root 3 minus 1 whole raised to 5 divided by 2 raised to 6. Yeah. So root 3 plus 1 into root 3 minus 1, that is in the form of a plus b into a minus b. So that will be a square minus b square. That is 3 minus 1 into, here we have root 3 minus 1 whole raised to 5 divided by 2 raised to 6, which is 32, right? Okay. So 3 minus 2 is 2. 2 into root, wait, what is 2 raised to 6? 64 it is, huh? 2 2s are 4, 4 2s are 8, 8 2s are 16, 32, 64. Okay. 2 raised to 6 is 64. So whole raised to 5 divided by 64. So we can cut the 2 and the 64, that will become 32. Okay, that's your final answer. Root 3 minus 1 whole raised to 5 divided by 32. Okay, now what we did is here is we rationalize the value of R. You can do it without rationalizing also. That's what Yvonne had done. Without rationalizing, we still get the same answer. Okay, rationalizing the denominator of the R is optional. Yeah, I'll solve it here without rationalizing the denominator. That's what we did first, actually. Okay, so if we don't rationalize the denominator, this is the formula: a into r raised to 6. R is 1 upon root 3 plus 1, so that raised to 6. So we'll get 1 and 6 as the powers, which we'll subtract, and that will become minus 5 on the numerator. We take it in the denominator, that will be raised to 5. Now we can rationalize this. Rationalize this meaning multiply this with root 3 minus 1 whole raised to 6 upon root 3 minus 1 whole raised to 6. Correct? Oh yeah, sorry, 5. This is all 5.
That means up also it's 5.
No, here it was 1 and 6. So when you subtracted 1 minus 6, it became minus 5 in the numerator. So that when we took in the denominator, the minus 5 changed to plus 5.
Okay.
Okay, so now what? This is a plus b whole raised to 5 into a minus b whole raised to 5. So what will that become? Okay, so root 3 minus 1 whole raised to 5 upon
3 minus 1 whole raised to 5.
Like this. So root 3 plus 1 into root 3 minus 1 whole raised to 5. Okay, because powers are same, we can take common power. So numerator is root 3 minus 1 whole raised to 5 upon, now denominator is a plus b into a minus b. So that will be a square, which is 3 minus 1, and that whole raised to 5, which is root 3 minus 1 whole raised to 5 divided by 3 minus 1, that is 2. 2 raised to 5, which is 32. Okay, so both ways, whether we rationalize the denominator or not, for r, we're getting the same answer. Yeah, so these you need to be very sure of this chapter. This is what fractions, rational numbers, rationalizing denominator, what we learned in 9th standard. Okay, what's the next out? 7th. Find the next two terms of the series. Okay, what's the doubt? Who did this? Sure. Huh? So the first term is 2, second term is minus 6. Third term is plus 18. Next term is minus 54, like that. So they wrote it, they didn't put commas in between. Okay, that's where the confusion is. Okay, so what's the first term? 2. Second term is minus 6. Third term is plus 18. Next term is minus 54. So using that, we know what is A. A is the first term, 2. The ratio R will be minus 6 upon 2. That is minus 3. That is your R. So we have A, we have R. We can find any term. Okay. Yeah. To understand the question, then you can do it. See, what they did is here, they added all the terms of the series. That's why you have no commas in between. Is that clear for everyone? Okay, what are the doubt? General term. Oh, okay. 16th question. If the 4th and the 9th term of a GP are 54 and this number, find the GP, also find its general term. General term means like you're modifying the TN formula for this particular question. That's the meaning of general term. Like normally, what's the formula for TN? What's the TN formula? AR raised to n minus 1. This is the general formula for any term, any GP. This is the formula to find TN. Here they're asking you to modify this Tn by substituting the value of A and R. Leave n as it is because we don't know what term we are finding, but we know what is A and R for this particular GP. Okay, so once you substitute the value of A and R, you will get the formula for the general term. Means to find Tn for this particular GP. That's what they're asking. You're finding Tn after substituting the value of A and R, not N. Put A, put R, leave N as it is N. Then that will be the formula to find Tn for this particular GP. Got it? So you can find the fourth term. I mean, fourth term and ninth term you can get, and then simultaneously we have to solve them. We have done a question like this yesterday. How do we simultaneously solve these two? Do we add or subtract? We have to divide, right? Take the bigger term, the ninth term, divide by the fourth term. So then we can subtract the powers and we can find A or A and R. After finding A and R, you can find the GP, means find the first term, second term, third term, and put dot dot dot. So that's at least 3 terms. And then put the value of A and R in this formula to find the general term. Is that clear, everyone? How many of you tried this? You tried. You tried? You said you tried? 15. What, Ahmed, you're saying something?
So can you repeat that again? Your voice is going.
Okay. Start off. I will do it here for you. Fourth term. Okay. T4 and T9. Okay. You'll get 2 equations. Simultaneously solve them to find A and R. Using that A and R, you can find the GP. And then to find the general term, substitute the value of A and R in this equation, Tn, and you'll get the general term. Okay, I'll do it here. You also can start doing. Ahmed. So what we're getting here is R raised to 5 is equal to 243. Okay, so we can find R by doing fifth root of 243. Does it have a fifth root? Is it 3? Okay, so R is equal to 3. Fifth root means 3 raised to 5 will be 243. So substitute the value of R in equation 1. So that is AR raised to 3 is equal to 54. So A into 3 raised to 3 is equal to 54. That is 27. A is equal to 54. A is equal to 54 upon 27. So A is equal to 2. Okay, so we got A and R. We can find the GP. Okay, the first term or T1 is AR raised to 0, which means 2. 2 into 3 raised to 0, which is 2. Then T2 is AR raised to 1. That is 2 into 3 raised to 1, 6. T3. So like that, you find 3 or 4 terms. Okay. So then write like this GP 2, 6, 18 comma 54, comma dot dot dot. That is your GP. Next question is find the general term. So general term means put this value of A and R in the formula. Tn is equal to AR raised to n minus 1. So Tn is equal to 2 into 3 raised to n minus 1. Is this how they stopped it, or did they solve it more in the answer you checked? Just check someone. This could be the general formula, otherwise they can solve it and do one more step. Yeah, you can do one more step. What's the answer in the book?
Same
only?
answer.
But if you have to solve one more step, how will that be? So this 3 raised to n minus 1, we can write it as 3 raised to n upon 3 raised to 1. Can we? Indices, no? The second law, it's normally done the reverse order. Right, if we have the same base and division in between, we will subtract the powers. Right? Yeah. So then you can write this as 2 upon 3 into 3 raised to n. So this is another form of the same formula. Anyway, you can't cut 2 and 3, so there's no point of making this. If you could cut the 2 and the 3, then this would have been a more easier formula, right? Here we can't cut 2 and 3, so this itself is this is enough. Seventeenth, the fifth, eighth, and 11th terms of a GP are P, Q, and R. Show that Q. Okay. Did you all finish writing this? See, like the 17th question, normally they won't come because there's no numbers. So you have to somehow try this way, that way, and if you get, you get. Otherwise, it's. You tried anything? You didn't try anything. Okay. Let me try doing. I'm not sure if I'll get. Let's see. So fifth term, eighth term, and 11th term are P, Q, and R. That means T5, which is AR raised to 4, is P. Then T8. T8 means AR raised to 7 is Q.
Q.
And T11, which is AR raised to 10,
10.
is R.
R.
Now they're saying,
In this
show
question, we have
that,
to prove.
yeah, you have to prove that Q square is equal to PR. It's not equal. We don't know if it's equal. We have to show that. So we can substitute the values that we got here in this equation and then solve LHS, solve RHS, then we should get the same values. Okay. So LHS is what? Q. Q square means AR raised to 7 whole square. And P into R, P is AR raised to 4 into AR raised to 10. Right. So solve LHS, solve RHS separately, and see if we're getting the same value on both sides. Okay. So what will LHS become? LHS is A square R
R 14.
14. Okay. And RHS is what? A into A square. R raised to 4 into R raised to 10 is R raised to 14. Okay. It's coming same. You understood what we did? LHS,
Yes.
we're applying the A square, and 7 into 2, we have to multiply 7 into 2. So that's how we got R raised to 14. And for RHS, we have to multiply A with the A's and R with the R's. So A into A is A square. R raised to 4 into R raised to 10, we will add the powers. That's how we got R raised to 14. Okay, so hence proved. Yeah, that's all it is. Okay, you can write that down. We go to the We'll go to sum. Next formula. All right, so we're done with this finding the nth term. We will go to finding the sum of a GP. Okay. Now in AP, how many formulas did we have for finding the sum?
2.
2 formulas. Do you remember the formulas? What is the first formula
Yes.
to find the sum?
S is equal to N plus
N upon 2. Clear? Tell me. Forgot. You can't forget old chapters. When you're learning new chapters, you have to keep revising. N upon 2 into 2a plus n minus 1 into d. That is one formula. The second formula to find S, if you had L instead
L
of D.
plus A. L plus A.
N upon 2 into A plus L. N upon 2 into A plus L. Those are the formulas. Okay, please don't forget. Okay, now here to find the sum, you have 3 formulas. Okay. Now look at an AP. We have 3 conditions. Okay, to find sum, we have 3 conditions. One where R is equal to 1, one where R is less than 1, the absolute value of R. Okay, and one where the absolute value of R is greater than 1. Okay. First of all, when R is 1, give me an example of a GP where R is 1. Are you sure? It'll be the same
1,
number. For example, 5, 5, 5, 5, 5. See, this is a GP where R is 1. If you divide any two consecutive terms of the GP, 5 divided by 5, what you'll get? 1. Okay. So a GP that has R as 1 will look like this. It'll be the same terms. Okay. Okay, let's put one more 5. So this GP has how many terms? 6 terms. So if you want to find the sum of this, how do we find it? 5 plus 5 plus 5 plus 5 plus 5 plus 5. Is there any easier way? 5 into 6. Right. So you can take, say, the first term, which is 5, and multiply it with the number of terms. Correct, no? In this, what is n? N is 6. There are 6 terms. And a, the first term is 5. So you multiply n into a, you will get the sum. Correct? So this is the formula that we'll use if R is 1, which never happens. Right? You'll never get GP like this. Okay, but in case there is, then this is the formula. Now the next 2 formulas are what you will be using more often. Okay. So in the second one, the absolute value of R should be less than 1. Absolute value means don't look at the sign. Just the ratio R should be less than 1. In other words, if it's a fraction, the fraction should be a proper fraction. The numerator should be less than the denominator. See, this is an example where this value is less than 1. Another example, minus 3 upon 7. Doesn't matter what the sign is. The only condition, the numerator should be less than the denominator. Such a fraction is called a proper fraction, and its value is less than 1. Its absolute value is less than 1. In this case, the formula to find sum of n terms is a into 1 minus r raised to n upon 1 minus r. Okay. Let me show you the next one also, then you can compare both and you'll understand why we are using this formula. In the third condition, the absolute value of r is greater than 1, which means r is a improper fraction. For example, 5 upon 4, something like that, where the numerator is greater than the denominator. So here, the formula a into r raised to n minus 1 upon r minus 1. Instead of 1 minus r, we're taking r minus 1. Why? See, in the first case, r is less than 1. So we're putting the bigger value first, 1 minus the smaller value. In the second case, r is greater than 1. So we're putting the big value minus the small value. That's all. So when you're subtracting, you're just putting the big value front. That's the only difference. Do you understand the difference between both these formulas? Okay, the rest of it you just memorize. Okay, so S and sum of n is what? A into 1 minus r raised to n or r raised to n minus 1, depends on what is bigger. Correct. If 1 is bigger, then you put 1 first. If r is bigger, then you put r first. Is everyone clear? Write down these three formulas. You all rejoin the meeting. Okay, question 2.1. So we need A, we need R, we need N. That is three things we need, right? A, R, and N to find the sum. So A is 1. What is R?
3.
3. Just do 3 divided by 1 or 9 divided by 3. Right, so that is 3. And N is the number of terms. That is 12 terms. So which is the formula that we'll be using to find sum?
Third
A
formula, A into r raised to n minus 1
raised to
upon
N
r minus 1.
upon R minus 1. Okay, come on, substitute and solve it and tell me the answer. Check the answer. Did they write it in terms of 3 raised to 12 or did they solve 3 raised to 12? Oh, sorry, R. 3 minus 1.
1/2 inside the bracket 3 raised to 12 minus 1.
Yeah, so don't solve the 3 raised to 12. That will take ages. You'll have to do 3 into 3 12 times, right? So they don't expect you to write such a big answer, okay? So leave the 3 raised to 12 minus 1 as it is, okay? And just solve the denominator, which is 3 minus 1, that's 2. So write it like this, 1 upon 2 into 3 raised to 12 minus 1. It's like this, right? Yeah, that's the answer.
We cannot write like that 3 raised to 12 minus 1 upon 2.
Yeah, you can write like that also, but normally whenever there's a denominator, we take it out separately. That is one standard that's used every time. Okay. How did you solve this in school? Like, did you do most of the sums or why? I mean, it's not taught yet. Okay. Last
In
year,
our
this
class,
limited actually, it was not there, huh? For
in our
last
class we have
it was
done.
not there. From before COVID, it was not there. It came back now. I think last year it was there. What are you saying, Amit?
In our class we have done this chapter.
You didn't do.
Did.
Oh, you did. Okay, so did you do all the sums or like few sums here and there or what? Which all you did?
Almost all the sums, only like 4 or 5 sums ma'am give for homework.
Okay. Okay, all of you do 2, 4 as the next question. 2, 4.
Take that minus
What, Amit?
to find our, we have to take minus 1 upon 3 divided by 1.
Yes, which is minus 1 upon 3 only.
So,
So R is minus 1 upon 3 and N, what they're asking? N terms. So we don't have any value for N. We leave it as N itself. So sum of N terms, the formula A into here, what is big? R or 1? I mean,
1.
1 is bigger than R, right?
Yes.
So it will be 1 minus R raised to N upon 1 minus R. So that is 1 into, we don't have to write the 1. So it is just 1 minus 1 upon 3, right? Raised to n upon 1 minus 1 upon 3. Denominator we can solve, numerator we can't do anything, right? Can we make this minus into plus? We can't.
Yes.
No, we can't. See, this minus will become plus based on the value of n. If n is even, then that minus 1 upon 3 will become plus, or minus will become plus. If n is odd, it will remain as minus. So we can't just change the minus into plus. Denominator will be what? 3 multiplies is 3 here, so 3 plus 1, 4 upon 3.
4 upon 3.
That 4 upon 3, you can take it in the front or leave it like this. How's the answer behind?
3 upon
Hmm.
1.
So we'll take this we'll change the division to multiplication. So 4 upon 3 will get reciprocal and become 3 upon 4. So 3 upon 4 into 1 minus 1 upon 3 whole raised to n. Is this the answer? Okay, let's do a usable type of question here. Okay, usable in daily life. A boy spends rupees 10 on the first day, 20 on the second day, 40 on the third day, and so on. Find how much in all will he spend in 12 days. So this is quite simple and more understandable. It's more all of numbers. So we have the GP here. First day 10, second day 20, third day 40. Okay, so 20 plus 30 plus 40 and so on. We have A, we have R. What is R here?
R. 2.
2. And we have N, which is 12. Okay, do this one, everyone.
We have to use third formula.
Huh? Yeah, 12 days. Sum of 12 days. Okay, how do we do this? L is given. We don't need L, no? Anyone, any idea? What we don't have is A. We don't have A and we don't have N. So what's the formula here is S is equal to LR minus A upon R minus 1. So here we have first term, last term, the sum and the ratio. So we have all of this except L. Our aim is to find L. So you can just simply put the values in this formula and get it then. So sum is 728. 728 is equal to the last term, we don't know L. Oh, we have the last term.
Last one 486.
Yeah. We don't have the first term. So A is missing. Okay, done everyone? Last formula. So there is extra formulas here. One formula. How to find the geometric mean between two numbers. Suppose you have a number A and B and you have to find the geometric mean in between.
G is equal to N to B.
What is mean? Normally mean. Mean, how do you find the mean between two numbers is you will do A plus B divided by 2. This is not same as that, okay? For example, if I give you two numbers 3 and 12. Yeah, I think it should be the... Let's see. See, what is the mean between 3 and 12? How will you find the mean? Normal mean, this is other chapter, mean. You'll do 3 plus 12. Arithmetic mean is 3 plus 12 divided by 2. This is arithmetic mean. 3 plus 12 divided by 2. So that is 15 upon 2, which is 7.5. Okay, so 7.5 is the arithmetic mean between 3 and 12. Here you're not finding arithmetic mean, you're finding geometrical mean. Okay. Arithmetic mean means there is a common difference between all these three terms. But geometrical mean means you will find a common ratio between the three terms. Okay. So if your first term is 3, second term is, our aim is to find the G, we'll take it as G, geometrical mean. What we know is that the ratio is common. The ratio is same between both. Ratio means what? How do you find the ratio? G upon 3. That's the ratio. That will be equal to this side ratio also. What's the ratio over here? 12 upon G.
G.
If you cross multiply this, you'll get G square is equal to 12 into 3. And G will be equal to, square root of 12 into 3. Right? That means G will be square root of 36, which will be 6. Okay. So using this, we can make an equation. So the equation to find geometrical mean is square root of the first term into the last term. This is your formula to find the geometrical mean. Square root of the first term and the last term. Or last term and first term, whichever order, multiplication. Okay, you just need to know this one formula. Just look at two examples in your book. See the geometric mean between 3 and 12. They're just doing square root of 3 into 12 and you're getting 6. Geometric mean between 3 and 243. Square root of 3 into 243. So that is square root of 729, which is 27. Okay. So just write this one formula. That's all we need for finding geometrical mean. G is equal to square root of A into B. Okay, we'll stop with this. This chapter is done. Please try out questions. This chapter, as you can see, is a little confusing. Okay, so work out as many questions as you can. Tomorrow, you don't have any practice, right? Okay. So 5 to 6 will be your tuition time. Okay, that's a time for every Friday. If you don't have practice, 5 to 6. Only 1 hour on Fridays. Okay, then see you all tomorrow.
5 to 6.
Yeah, what am I?
The 5 to 6.
He was here. Ryan, you said you're reaching in 10 minutes and where you reached?
Anna, I was going to come, then it started raining
Okay.
and it stopped. And then
Huh?
again it started raining. I was like, I'm not coming.
Okay, no problem. All right. Amit is very sad. Okay, listen here. 20th question, everyone. Find a GP for which the sum of the first two terms is -4 and the fifth term is 4 times the third term. Okay, anyone tried this out? Okay. Equation. Ryan and Nathan, put your cameras on. Find a GP for which the sum of the first two terms is -4. First two terms means T1. Tell me what's the equation? T1 plus T1 plus T2 is equal to -4. T1 plus T2 is equal to -4. Okay, and what's the second equation? T5 is T5 is equal to 4 times the third term. 4 into T3. Correct? Yeah, so you got equations. What happened, Aman? Aman, understood? So simplify the first equation. In place of T1, we'll put A. And in place of T2, we'll put AR raised to 1. Right? Or that's AR is equal to minus 4. Simplify this. A plus AR. How do we simplify this? Huh? What is A plus AR? You can't add. What you can do is you can take common A outside. If you take A outside common, then you'll have 1 plus R is equal to minus 4. Correct? Yeah, that's what we can do here. Second equation also do the same thing. So T5 means AR raised to 4 is equal to 4 into AR raised to 3. Yeah. We can cut the A and the A over here because it's all multiplication in between. And which one? 4AR raised to 2. Correct. Okay. So A and A is cut. So what we have? R4 is equal to 4 R2. So take the R on the left side. So R4 upon R2, R square is equal to 4. So R square is equal to 4. You have to minus those 2. Therefore, R is equal to 2. Okay. Put this value of R in equation 1. So equation 1 will become A into 1 plus 2 is equal to minus 4. This equation is. So 3A is equal to minus 4. A is equal to minus 4 upon 3. So we got R, we got A. Now we have to find the GP. So substitute that, find the first 3 terms of the GP. A, AR, and AR raised to 2. Maybe AR raised to 3. Okay. Are you all done? So what is the GP that you got? Minus 4 upon 3, comma, minus 8 upon 3, minus 16 upon 3, minus 32 upon 3, and so on. Correct? Okay. Any other doubt from GP? Or we'll put an end to GP. Okay. Which one? This is 20th only, no? I solved R and A. Which you want me to solve? How we got this?
Yeah.
We're done with the chapter. This is the first topic. T1. T1 is A. A is minus 4 upon 3. We have that. T2 is AR. T3 is what? Huh? AR square. T4 is what? AR cube. Yeah. So just put the value. Substitution this is. A is minus 4 upon 3 into R. R is what? 2. That's how we got this minus 8 upon 3. Then AR square is minus 4 upon 3 into 2 square. 2 square 4. 4 fours are 16. Substitution.